Well, hi, good morning. Thanks so much for joining me here in my shop for a bit of a late start this morning. And what is going on with this radio? Oh, that's a good question. Or more specifically, what is going on with the antenna on this radio? So I'm just going to review a couple things to get them straight in my head, or somewhat straight in my head. First of all, the schematic doesn't seem to match the antenna. The schematic describes a very simple antenna arrangement. This does not seem to be simple. That's about all I know. I can't say too much more about it yet. I'm guessing one possibility here is someone previously removed the antenna, and when they reinstalled it, they hooked up the wires incorrectly, and that's part of why it's driving me a little crazy to sort this out. The other reason, it's probably a more likely reason, is I'm just looking for a pencil here. Now let's try this navy blue. The other reason kind of goes like this. We have this loop on the back here, which I'm just going to draw like this. There's the loop. It's got an end. There's an end. It's got another end. There's another end. It has to have two ends, at least. It could have four ends. There could be two loops. There could be another loop in here. I'll draw it heavier here. It could be another loop. And there could be two more ends. And it could be that there's really one loop of wire with a tap. This could be connected here. And it could be a tap. That would be three wires coming out the back. They're coming out of the actual, not these wires. Oops. Not these wires going to the radio, but the wires actually coming out of the loop. I can see one coming here, one coming here, one coming up here, and one more coming over on this side here. What they look like, if I draw this pictorially here, that's not coming through on the camera very good, is it? I'm going to draw another antenna here. It looks like this. One on the inside, three on the outside. So we can guess that the one on the inside has to be, this is a stupid statement, but has to be involved with the antenna. They all have to be involved with the antenna. But this one will lead to a lot of loops of the wire and eventually arrive at the outside where we have these three. You could assume one of these three, I could assume, is the end of the main loop. It would be here, I guess, the way I drew this before. And the other two could be a separate loop, like I said, or who knows? Who knows what they've done in here? Now on the schematic, there's nothing here but one loop, one side grounded, and the other side going into the radio. But that's not what's going on with this. So, how to sort this out? I don't have a schematic to follow. And so far, in trying to examine these three wires, I've been unable to make any determination about them. Now, the weirdest thing of all is one of these outside wires, let's say it's this one, comes to a terminal. There's a terminal here. And the way I found the radio, this wire was separated from the terminal and just sitting right next to it. And the way it looks, the way it's bent, the way everything is, it sure looks like it should be on this terminal. I mean, anybody would reach the same conclusion. It's broken off for some reason from this terminal, and it should be reconnected. And that's the wire. I know you can't see it from that distance, but it's right here. I mean, it absolutely must go to this terminal. This terminal attaches to the screw on the back. But with the radio operating and receiving a station, with the antenna as it is, with this wire separated here, the radio receives. And not too bad, not too badly. Any radio that can pick up anything in my shop is doing okay to begin with. But this one was picking up 590, the sports channel, quite clearly. And the antenna was exhibiting directional qualities. As I rotated the radio around, the reception went up and down, suggesting the antenna is doing its thing with the wire disconnected. So, what to do? Why not connect the wire? So at the end of the last video, you see me temporarily contacting this wire against the terminal that it came from, and the radio goes completely dead. And that was so anomalous to me, that ended it. That ended it on that day. That was just yeah, that's like 2 plus 2 adding up to 5 right in front of your face. So that's where I am now. I am looking at this and wondering, well, how could it be the case that you reconnect a wire to where it's supposed to go and the radio goes dead? How could that be? Now, there is a capacitor up here. Off camera, I did test it with my own meter. It's not shorted. There's a capacitor here. It's a mica capacitor. I have not tested it in any way, but I can't imagine it's shorted. It's possible. Not terribly likely. It's another weirdness about this antenna. Another thing that really makes me wonder about the whole deal. So behind this metal bracket are 2 terminals that you're having some trouble seeing. There they are there. 2 terminals. One has a capacitor. That one is going into the radio. I mean, you can see the capacitor lead is disappearing into the chassis there. The other terminal is a ground terminal. Can you see that terminal is bolted right to the chassis? It's a chassis ground terminal with 2 wires coming off of it. 2 wires. Now those 2 wires, this is the weird part, those 2 wires travel separately to 2 terminals that are side by side up here. So wouldn't anybody connect those terminals together here and run 1 wire to the ground? Why would you have 2 wires? My guess on this is this antenna was manufactured for a couple different versions of this radio, or in fact to go into other radios. I don't know this to be the case. I'm just making this up. And so this is being built on a bench separate from the actual manufacturing line for the radio. So some guys busily building these things, or a couple people. Maybe they have a little assembly line for these antennas. And they're building them away, and then they are supplied to the main assembly line to go onto a radio. Now, it could be the case that there's this many wires coming out of it because in different radios, these wires go to different places. So in this radio, you put these 2 wires to the ground terminal. Now, why bother with that? Well, because all these antennas are being made exactly the same. And so you'd have to, if you want to get 1 wire here, you'd have to get out and install a wire here and cut away this wire. Well, that's a waste now. It's a waste of effort because the wire's been installed. The easiest, cheapest thing to do is just solder both wires to the ground terminal on this model of radio. And that would be the instructions for it. That's the only way I can reason this out, because these radios are designed and built very miserly. So they wouldn't waste a piece of wire here. You know, I could build 1,000 of these radios. This is a fair bit of wire here, which they could replace with a little tiny piece up here. Some guy could make put it in the suggestion plan and make $5 with this great suggestion. So there's just really a lot of question marks around this antenna. And I don't really have the correct answers here for it. The wire, both the wire in the basket winding and the wire in the actual antenna winding, what I believe to be the actual antenna winding, well, they're insulated with cloth, maybe some other stuff too. So they're not it's not easy to access them for testing purposes. And if I were to look at this as a 2-coil arrangement, say, well, just get out your ohm meter and measure one, measure from here, measure there, measure all around. So you can use this diagram. Sooner or later, you'll figure out what is connected to what and what is not connected to what. The problem with that, well, you know what? I haven't thought that through 100% yet. So if there is 2 windings, yeah, I won't even finish what I was going to say because it actually doesn't add up. So I'm really stuck here as to what to do. I got a radio that works reasonably well with an antenna that appears to be discombobulated. Do I recombobulate it without instructions and somehow expect an improvement in the performance of the radio, which is already performing relatively well? And I guess the last crazy notion here is some real smart guy figured out that if you nip this wire here from the terminal, if you nip this wire, the radio will work better. Yeah, I have a lot of trouble with that story. So I don't know the story, don't know what's happening, don't know what I should do about it. That's kind of where I am with this situation. Yeah, I don't know. So I'm going to stop. I'm hoping the answer is in my cup of coffee here. I'll go see. Okay, here's a thought that's come to mind. If in fact the antenna over here is some antenna made for multiple radios, and then you might hook up the lead wires differently from the different models of radio, those models might be in this book. So I'm thinking if I look through some of the other models that were coming out in this age, 1939, 1940, maybe I can spot something that resembles the thing on the back of this radio. That's my thinking. So this is the radio that I'm looking at here, 24 or 24T for Toronto. It says right there actually, 24T. And I think the T is for Toronto where it was made. So here's another schematic right up here. And we can look at, this is the loop antenna, very simple arrangement here, which doesn't seem to match the actual antenna. So let's go. So here's another schematic. Now this is a real classic. You have the antenna, you have a primary on a transformer and going to ground, so the antenna signal is delivered into the secondary here and then on into the radio. This is usually a coil. I mean, you can spot it in the radio. It's quite obvious that this is a small coil, not a big antenna. That's the antenna up there. Okay, so let's just keep going back. Model 21. Now in this case, they've done something more complex. It's a little hard to see on the camera, maybe. How to interpret this diagram, I'm not sure. There's a dotted box around this part. That might make you think it's a coil, like an antenna coil. Where would you hook up the antenna? So there's no antenna symbol here to find. These are colored wires. They're getting the different colors. But look, it has some kind of coil arrangement here with 1, 2, 3, 4 wires coming out of it. Could this be the same antenna I have? And this is how they're showing it. Well, look, generally, I don't know about generally, they're showing antennas like this. Like this is clearly a pickup antenna, not a coil. And this is clearly a transformer, not a pickup antenna, or This is not quite so clear what they've done here. No place to hook up an external antenna in here. This is complicated here. What they've got is a little coil there. There's a resistor capacitor thing happening down here. Let's see another one. There's the same sort of thing here on this radio. Same sort of antenna arrangement. No. Well, there's a screw terminal for an antenna. Antenna and ground. Here's another one. Here it is here. Same sort of deal. I have to imagine this is a transformer. And this dotted line might even represent some kind of can around it. So the only antenna here would be the wire you hook up to this antenna connection. And what is all this switching? And look at all that. Yikes. I don't know what this is. Okay, another radio. This is a Philco. The year's not written here. Many, many models. Where's the schematic? This is the alignment data. Here we go. Here's another very similar arrangement. So they are using something similar, a similar approach. Why? It's the same engineers designing all this stuff. Same guys coming up with the same basic solutions. Same thing here, here. Antenna ground. There's an antenna input quite clearly there. So this would come around, work its way up. I think it would work its way to the grid despite this. This is showing again in this box. It's got a number 1 on it. They number these boxes, but where's that number reflected? Number 1. No, that's the steps of alignment. I don't know where that number's. Antenna tuning stage for model 23, and they're pointing. What are they pointing? They're pointing at all this. Antenna tuning stage. See figure 3 for antenna stage for model 18. Antenna stage. Again, it's the same arrangement every time. These weren't the most creative engineers. Okay, now here we've got the antenna and a transformer. It's got this curious little sort of shorted winding on the primary side. Isn't that interesting? I think, oh, here we are. Look at this. Here's an antenna. So this is clearly an antenna. There's the antenna screw. Oh, this is going right around. Did I see that right? It comes down, comes across. Yeah, this is showing it as part of this. And the end of this is, well, where are you? I'm going around and this is a square. Wait a minute. Here we are. We go here. It's complicated. Capacitor there, coil here, some kind of switching thing happening there. Well, the engineers really worked on the antenna side of things, of course. You know, if the antenna's poor, the whole radio is poor. So, complicated. And they got this, and this. Models 12, model 14, 12 and 27, 10. I guess they're just totally different radios here. They look. Well, see, they're all using the same first tube, 7A8, which I think wasn't a lot to choose from back then. Don't think this is helping me clear anything out. Okay, now we're on Northern Electric. This is a totally different. This is totally different. There's a Philco. This is 39 to 40. Loop antenna. One wire coming down to ground. Oh, it's got antenna and ground up here. Antenna to ground. This doesn't make sense to me either, really. Ground. So I guess the antenna is not really directly connected into the radio. It's simply this antenna part is acting as a transformer if you hook up an external wire. Otherwise, this coil is the antenna. Well, that's kind of the arrangement I would think you would find with the radio I'm working on. That's what the schematic shows, in fact. This kind of antenna. The schematic I have. There it is again up here. this is very understandable. Now we're going to even simpler types of antennas here. Nothing like what I've got. Still a Philco. There's a Philco 39 to 40. So the Philco engineers certainly put effort into the antenna. They've come up with some interesting things to do here. Antenna compensating condenser. Antenna compensator. So there's a capacitor there, capacitor here, compensator. And then this is a Fanola, is another manufacturer now. So we've looked at all the Philcos that were put out, at least here in Canada, in 1939, 1940. That didn't help. It's a good idea, but it didn't really help. But it does show that the Philco engineers were really into trying to work out the antenna situation. Doesn't help with this. What am I going to do with this? What is this white paint here for? That's kind of weird. Why would somebody put a blob of white paint on here? And the answer's not coming. Oh, I scared the heck out of me. Peanut, I was just with you, buddy. Where are you? There you are. What's the problem? Peanut. Yeah, what's the problem today? Yeah, it's raining outside. Christmas Day, we had 3 feet of snow. Today, the snow is about that much left, and it's raining on it. It's all going away. Strange weather here. It's not helping with this antenna. Okay, Peanut, I'm coming, because I don't know what to do here. Well, it's actually the next day, and I'm looking at this cuckoo radio, and I do not know what to do about the antenna. I can't come up with some logical way forward with it. And what's the matter with it? Radio seems to work, but when I hook up the broken wire to where it obviously should go, it stops working. Well, I didn't investigate that very far, actually, the stopping of the working. It sure seemed to kill it dead. So, my gosh. So I was thinking more about this unusual winding of a wire around the outside of the main antenna. And one end of that wire is just ending over here. The wire's actually broken in the middle here, but let's suppose it wasn't broken. And the other end of it is here, coming over to this terminal, excuse me, which is tied to ground. So as it stands, this piece of wire, which I think is supposed to be extended by an external antenna, and then this would form a transformer with the other windings in here, and that way you'd get your external antenna signal into the regular antenna. But as it stands right now, this is a pile of grounded wire wrapped around the antenna. Now, what sense does that make? That doesn't make any sense. Why? You could imagine that perhaps the end of this wire should really be attached to the external antenna screw, but it certainly isn't. Other things are attached there. But even if you had this attached to the external antenna screw and you did not have an external antenna, you would have a grounded basket of wire wrapped around your antenna. Surely to goodness that's not a good thing, is it? It just seems that seems counterproductive to me. You would think now, as it stands, this wound wire is going nowhere except to the break here, and it can be nothing more than a grounded thing. Surely it's interfering with the operation of the antenna. But the antenna works with this grounded basket and a broken wire. I'm still baffled at the two ground wires coming down here. I mean, is it what's happened here? Somebody has removed these wires from the terminals here to do something, and when they've put the wires back on, they've done it wrong. And I'm looking at a miswired antenna, which doesn't in any way match the schematic that I have, or any other that I could find. What a quandary. I mean, I'm thinking, surely to goodness, if this is straightened out, this radio is going to work really well. Look at this fancy antenna here. But it's already working fairly well. So this lead is the lead that attaches to the tuning capacitors, either the main variable frequency oscillator capacitor or these push buttons. So this engages the capacitance against the coil of the antenna. This terminal down here with the capacitor is the way in which the actual antenna signal gets into the radio. And the capacitor keeps the AVC voltage that's applied to the grid on the tube here from coming back into the antenna and eventually probably discovering ground and being grounded out. So that's the purpose of this little capacitor. You have two ground wires coming back, different colors, each one going to a separate terminal, but the terminals are side by side. And to one of these terminals is this basket wire. Also attached to the ground is this capacitor. The other side of this capacitor, this is a .0015 capacitor. I don't remember seeing that on the schematic. It comes over to this terminal, and then attached to this terminal is a wire that's going down into the antenna proper. It looks like it's going down to the inside, but it's not. It's actually going to the outside. And it's one of three wires that lead to the outside. 2, 3. The only wire leading to the inside of the big coil is this one. Here. And this one is attached as if it's, this might help out. This is attached here where the tuning capacitors are and where the signal's going into the radio. So we could think of this wire as the output of the antenna, or the input to the radio, depending upon how you want to look at it. This is where antenna meets radio, right here. There is an extended wire, a uninsulated wire coming down to the external screw for adding an external antenna. That external antenna would be connected just simply directly to the radio, to the tuning capacitor. Nothing fancy going on with that. There's nothing to do with this capacitor here. It's all kind of weird. The reason I say it's weird, it's not connected to the capacitor. Sometimes you'll find a radio with a ability to extend a wire out, and there'll be a capacitor in the circuit to protect you because it could be a hot chassis radio, such as this one. This one was. So 3 wires to the outside, 1 to the inside. The one on the inside must be attached to basically the bulk of the wire, because it's got to go all the way around to get to the outside. And then it's going to come back on one of these 3 wires. So I've examined them to see if I can recognize which wire is the inside of the outside wires. And there was a little hint. There's a wire coming through right on the outside. Another wire coming through right on the outside also. And then we have a wire coming through not quite on the outside. So you could almost imagine that this goes around basically once. If it went around once, there would be a turn beyond the end turn of the main body. And that's what I'm seeing here. So we could deduce, maybe from that, that the main body of the antenna is this wire here, which is coming to the grounded terminal. So what I'm seeing now is we have the main body of the winding. One side connected to the antenna input to the radio, and the other side grounded. That would be it. What would these other things be then? So the other two wires going to the outside could be for a turn or two around the outside. What good would that be? Those other two wires, one is here, that's the broken one, and the other wire is here, it's grounded. So if that's the case, then we have a short piece of wire, one end grounded and the other end cut off or broken off, which is basically an extension of the ground. It just goes around once. So when I took this wire, a broken wire, and touched it back to this terminal is tied back to the main antenna. I was basically putting a ground on the antenna. So that would explain why a signal just disappeared. And also explain why the radio is working fairly well, because it has the bulk of this antenna connected to it. And all the fancy schmancy stuff going on is not doing anything. Fancy schmancy, we're talking about these wires and talking about the extra turn. Okay, so if one side of the outside turn, let's call it an outside turn. If the outside turn, one side is grounded, and the other side, is broken off. Right, it's disconnected. It means the outside turn is really doing nothing, except it's more grounded wire next to this antenna. So this is the best I've figured this guy out at this point. Now what's the deal with the capacitor? The capacitor is connected to, wait a second here. I lost track of myself. If I'm thinking this is the outside, this is the main wire, it's connected. The main wire is connected to this capacitor, which is then connected to the grounded terminal. Okay, did I see that right? So we have the inside lead wire leading into the bulk of the antenna. And we have one coming out, I've identified just by its physical location right here, because there's a turn beyond. So this is the end of the coil, and it's tied back, it's tied back to the capacitor, which is then tied to ground. Why? That just seems a little odd to me. You would think they would wind the antenna to present the proper impedance to the size of capacitor they're using for tuning, which are almost always the same, roughly the same size. 0 to 300 picofarads, usually the tuning capacitor, something like that. So you're forced to wind the coil to match the capacitor. they've used a winding technique here where they're weaving the wire, so to speak, on this paper form, cardboard form. And I believe that's an attempt to reduce the capacitance of the winding. I guess you would do that. Why would you do that? I don't know offhand. That's why you'd be worried about the capacitance of the winding. Meanwhile, there's a capacitor here. What's this doing? In series with it. Time to study up a little more on antennas. I'm afraid the book is not going to be of much help here. Elements of radio servicing. This is the antenna section. Back here it shows you a very basic antenna, which I think is worth looking at right here. You see the antenna feeds a coil that's grounded. And that's the primary side of a transformer. They aren't showing the rest of the radio, but there's a secondary side, and that's what feeds. And a lot of antennas are done like this. Now if we come, this is just different variations. A lot of talk about stuff. We get here, this is a section on loop antennas, and they're showing one. And this matches the schematic that I have very, very closely. And you have the external antenna, there's a screw, according to the schematic, and then they literally show it going like that. It's a virtually identical diagram. And if we look at the loop, one side of the loop is going to ground. And the other side is of course going right off to the converter tube, RF tube, or whatever it might be next in line. This is kind of what's going on in this radio. Except there's an additional winding on the outside of this antenna with two leads coming out, one going to ground and the other cut or broken. Cut or broken. Like, who would know enough? Like, if, really, oh, look, why, they built the antenna with a ground on it. I'll just cut that wire and bingo, now it all works. That can't happen either. Too many mysteries here. There's a concern with the AVC voltage making it to the grid of the first tube through this arrangement. So there are steps taken to ensure the small DC AVC voltage can, in this case, sneak its way through the antenna and reach the grid that way. Don't think that's what's going on here. According to the schematic, which I realize now may not be correct, this capacitor here that I'm pointing at, see this little capacitor here, is blocking the AVC or protecting the AVC voltage that is applied to the grid of this tube here. So it can't come back into the antenna. So they're not trying to pass the AVC through the antenna. So I don't think that complication exists. Now here's a nice diagram in case you're ever confused about which way a loop antenna works. They're showing it here. This is the way you want the loop antenna points out the ends towards its stronger pickup direction. There's a very deep null this way, which is really the benefit of a loop antenna. The deep null for getting rid of stuff, interfering stuff. And this is just showing you how, again, there's a transformer in the radio, and that's it. That's it for that. It's not a lot here. A lot more in wire antennas. He's let me down. I don't think I've got any other books that go into any kind of detail that would cover this radio and the kind of thing that's going on here. And what is going on here? I don't know. So I think I've reasoned this out to the point where I should say, just leave it all alone. Don't fix this wire. Don't worry about this open end. This thing that's grounded here that I'm tempted to cut away because it's grounding the basket, I just leave it all. Just leave it all. Don't reconnect the wire that's not connected. And accept defeat on this in the sense that I really don't know that I'm doing the right thing. I really don't know what else to do about it. And I need to move on. So all that results in do nothing? Really? I think I'm going to go drink some coffee. Okay, so I discussed the situation at length with my coffee cup. The whole reason I'm investing time in this antenna, well, there's two reasons. One is it appears to be misconnected. And secondly, it's heavily engineered and designed, so I think there's some magic to be gotten out of this antenna, if it were connected correctly. And that's why I've spent all that time trying to sort out what to do about it. And in the course of doing that, discovering a number of anomalies about it, all of them raising the curiosity factor. In the end here, I'm sitting here thinking the best thing I can do is just leave it just as it is, bolt it back to the radio, and then test the radio's receptivity again, which the last time I ran it seemed to be outperforming most little radios like this here in my shop. So, that's another angle on this of what do I think I'm going to gain by fiddling around with this antenna when, as it is, it's receiving quite well. I don't think there's much more to gain, really. If you take a modern transistor radio, and I've never had a tube radio match something like this. This guy will pick up quite a number of AM stations here in my shop, and no other tube radio has ever been comparable, really. And maybe that says something about how well I'm doing at fixing these radios. I don't think so, though. So, given all this talk and all this thought, I really am at the point where I just put it back together, test the radio, ensure that its performance is pretty good, accept the situation for what it is, and I don't know what it is, and move on from there. What's left to do in this radio? There's a whole alignment I haven't done yet. So all these buttons that look pretty interesting to fool around with too. That's the plan. That's the plan. Put the antenna back on and move on. Okay, got the antenna stuck back on it. Let's turn this guy on and see what it can do. Very good. Okay, now hidden behind the radio is another junk box special of mine. This is a very simple antenna. I think it's very similar to this antenna, in fact. There's two loops on here. There's one that is the bulk of the wire, and then there's another once or twice around loop. So I'm not going to do anything with this right at the moment. You can pretend it's not even there, because it really isn't there as far as this radio is concerned. Just stick that over there. Here we go. Okay, Mr. Radio, what can you do all on your own here in my shop? Okay, it's already picking up something. Okay, so that's one station. Not super. Isn't this the wrong button? No, I don't. This is the right button. Just turning the radio around. Wasn't this working better before? Let's go up here. 860. this radio is working better. Let's go back to the one station it can pick up. See if we can boost this now a couple ways. External antenna. Or do we just add it right in? We just clip it here. Let's do that again with the ground connected this time. This is no different than hooking up to the screw on the back. Doesn't seem very helpful. No. Okay, now we're going to try to boost this antenna signal using this crazy coil here. I've had a little bit of success with this once in a while. Oh, that did it. Just putting it there, there's nothing hooked up to it. It's just sucking things right out. Now this is a tunable coil, I can tune it. Look at that. I may want to explain that one. If I tune this. Oh my gosh, hang on a second. How does it kill it? How does it kill the signal? It eats it. It's eating the signal there. We will now hook up the outdoor antenna. Let's see what happens. Hooking it up to this. Hooking it up to the single turn here. Can we boost it? Still destroys it. Well, you totally got me as to what's happening here. This is not really working the way it's supposed to. Where did I drop this just now? I don't know. Thought it got louder there for a moment. Well, this isn't helping one bit. It's just adding to my confusion, fascination. What's going on here? This thing in the back here is not connected any way to this radio. They are, well, they're connected by the fact that there's some coupling going on between these two. That's the extent of it. And as I'm tuning this capacitor back here, we should be resonating this coil at throughout the AM radio range. Doesn't seem to want to do that. Certainly has some strange effects though. I don't know. Okay, this isn't helping, so we're going to put that aside. It is helping. Ooh. It's my hand. I'm helping. Tuning. It's behaving a little more normal now. Still need my hand on it. Yeah, that doesn't seem to help at all, does it? Okay. Once again, my concept of how things should work doesn't add up with reality. So, back to just checking this radio. So this will be the best alignment for a station from Toronto. That's from Toronto. Right there. That's another Toronto station, 680. I think that's St. Catharines, 710. That's the French station at 860. Well, that's not bad. That's, for here in my shop, this radio's working about as good as you could expect. Let's push some of these buttons up here and see what happens. No idea if they're tuned to anything in particular. Here we go. I mean, it has to be tuned to one of these stations I can get. See how the switch operates here with these sliding pieces. And there's dirt all over them. That's probably one. That's the VFO again. So let's go down to 590. Where'd it go? Hello, calling on 590. Shouldn't have pushed these buttons. Let's give them a bit of a cleanup here. I don't want to spray this onto a tube. Hey, where'd you go? let's tune this button to that same station. So these two, one is the oscillator, and the other one is the antenna tuning trimmer. Which one's which? So this one seems to tune it. This one seems to make it stronger or weaker. Okay, put a little screwdriver in there. I'm just winging this kind of. Look how the angle I got the radio on. I know it's got to be like this. Well, can't it be like this? It's exactly the same. Let's go back to VFO. There he is. We got to get that. Can we get there from here? So I have no idea what this is tuned to. It's pretty tight there. Some of these buttons in some radios are arranged so that, you know, the ones on the left do the low part of the band, and the ones in the middle do the middle part, and the ones in the top do the upper part. You can't cross over. They're range limited. These don't appear to be that. Okay. So we're going to have to turn on an oscillator and find out where the radio's tuned. Quite a range here. These are like precision capacitors. You get a lot of turns in the screw here to move the plate a little bit. These are really good. We're not finding the station though. Okay, next step is to turn on an oscillator. We'll find out where the radio is actually tuned. Where are we on the clock? Oh my gosh, it's lunchtime. Okay, and what we'll do with this, we're just going to lay this basically near the antenna here. It should be enough. Should be enough to... I'm going to guess we're going to get enough signal out of there. Okay, Mr. Radio, where are you tuned? So I'm going to turn the output up max. We're at 590. Let's go down. Looks like it's 560 is where it's tuned. So we want to move it towards 590. So we'll move this towards 590. Okay, and now we'll try to tune it back in. Whoa, that went quick. There we are. Okay, so this is 590 now. I think I can hear the radio station underneath it. 590, and then this is the antenna tuning. Give me a little boost. Very clear spot. Right there. Take this away. Hello, 590. Volume up a bit. I thought we had it. It's my hand getting near the antenna. Where'd you go? I don't get it. This is right here. I thought I could hear it. Okay, I'll put this back. Where are you, Mr. Radio Station? Let's go back to the variable frequency oscillator. That's what we should hear. We should hear that. Let's check the frequency again. It's a little low frequency-wise. That's 590. Adjusted with this. Now I have found on some radios recently that adjusting the antenna tuning can sometimes affect the oscillator at the same time. So let's try that. Maybe that's what's happening. You wouldn't want that to happen. Well, it's another curious thing here now. On push button, the reception's much worse. I'm not sure how much you ended up watching last night, but I mean, you know what happened and you know the names. Just mention a couple of them. So what's left in this radio? There's a couple of capacitors underneath. You can see one sticking out the side here. And a general alignment, even though the radio's operating quite well. A general alignment's probably worth doing. Why these aren't reacting, or the one I tried anyway isn't reacting as well as the main VFO, I'm not sure. I think electronically it's exactly the same thing as far as the radio knows. So why weaker? I don't know. That's the truth. I don't know. Okay, so that's it for today. Tomorrow I'll do the alignment, and this guy will be on his way. For the next person to fool around with. The main thing is the radio works. It's functional, and you can have some fun with it. And it's a nice looking case. So alignment tomorrow. See ya.